Okay, in this lesson we're looking at some different strategies for solving equations in the form x to the exponent n equals a, so some constant. So for example, to begin with, we have the equation x to the exponent 4 equals 16. So one way that we could solve an equation like that is by factoring. Now before we can factor, what we need to do is move all of our terms onto the left-hand side. So subtracting 16 from both sides will give us x to the exponent 4 minus 16 equals 0. Now that can be factored as the difference of squares. The square root of x to the exponent 4 is x squared, and the square root of 16 is 4. So we'll factor that as x squared minus 4 and x squared plus 4 equals 0. And then x squared minus 4 is a difference of squares again. So we'll factor that as x minus 2 times x plus 2 times x squared plus 4 equals 0. Now, repeating what we did in the last lesson, now we know one of these factors has to equal 0 in order for this equation to be true. So we know that either x minus 2 equals 0. I'm going to move up here where I have a bit more room. So x minus 2 equals 0. In which case x equals 2. Or x plus 2 equals 0. This is not writing very clearly once again. In which case x equals negative 2. Or x squared plus 4 equals 0, which actually can't happen because that would mean x squared is equal to negative 4. Excuse me. And x would be the square root of negative 4, which we can't do. So the only possible solutions here would be x equals 2 or negative 2. Now another way we could solve that same equation would be by graphing. So if we look at the associated graph of y equals x to the exponent 4, we could solve the equation x to the exponent 4 equals 16 by finding where on this graph y equals 16. So y equals 16 right along this line here. So we're interested in these 2 points on the graph where y equals 16. Then we look down to the x-axis and we see that our 2x values are negative 2 and 2. So x is equal to plus or minus 2. Same solution, of course, since it's the same question. And the final method we'll learn for solving this type of equation is just to take the nth root. Now you've got some rules to follow here that I will refer to as we go through these few examples. So x to the exponent 6 equals 1,000,000. That means x is equal to the 6th root of 1,000,000. Now you can find the 6th root using your calculator, but the 6th root of 1,000,000 is 10. Now, since we're taking the even root of a positive number, we know the answer could be both positive and negative. In other words, x could be plus or minus 10. So negative 10 to the exponent 6 is equal to 1,000,000. And positive 10 to the exponent 6 is equal to 1,000,000. So that one has two answers. Whereas if we're taking the cube root of 64 in the next one, we are taking an odd root of a positive number, so the answer will be positive. The answer will be positive 4. Again, you can use your calculator to find the cube root if you have trouble doing it mentally. Next one, x exponent 4 equals negative 500. So we would need to find the 4th root of negative 500. Now, the even root of a negative number does not exist, so there's no number that I could multiply by itself 4 times that would give me a negative answer, no matter what that negative number is. So we will draw 2 facing arrows here, which basically means there's no answer, or you can't do it. Okay, so there's no solution. And the last one, we need to find the fifth root of negative 32. That would be taking the odd root of a negative number. So the answer there'll be one answer, and it will be negative 2. So negative 2 to the exponent of 5 is negative 32. And that concludes this lesson.